Hey guys, we're going to go over the continuous random variable with normal CDF and inverse norm using the calculator. Okay, so the first one says a machine fastens plastic screw-on caps onto containers of mortar or oil. If the machine applies more torque than the cap can withstand, the cap will break. Both the torque applied and the strength of the caps vary. The capping machine torque T follows a normal distribution with 7 inches-pounds and standard deviation of 9.9 inch-pounds. The cap strength C, the torque that would break the cap, follows a normal distribution with mean 10 inch-pounds and standard deviation 1.2 inch-pounds. So it says, what is the probability that the random selected cap has a strength greater than 11 inch-pounds? Okay, so here we have two information. We have two standard normal distributions. We have the T, and we also have C. So we want to talk about cap strength since it's talking about cap strength here. Okay. So here we have a mean of 10 inch-pounds. We also have a standard deviation 1.2. We want to know what's the probability that it's greater than 11. Okay, so we want to know here's 11, and we want to know what's the probability that it's going to be greater than this right here. Okay, and the way you write it in notation, it's going to be what's the probability that C is going to be greater than 11. Okay, now if you notice on the calculator, I've showed you guys before that you guys need to do 1 minus the probability of C less than 11, simply because sometimes when you write it out, it gives you the area of the left. Now, there's other ways of writing it too, but I'm going to go ahead and show you this way, okay? All right, so now the way you're going to find this out is you're going to go to second bars, and you're going to go to normal CDF, and then you're going to enter the lower bound. So if we're going to do here, C is less than 11, the lower bound is going to be way over here. So I'm going to put a very large number. I'm going to put negative, let's say 10,000, okay? Comma to the upper bound, which is 11. So I'm going to put 11, okay, and then I'm going to put comma, and then I'm going to put the mean, which is 10, and the standard deviation, which is 1.2 inches, okay? So 1.2 inches. So now the probability is about 0.797 or 0.797. You put 0.797, so it's going to be 1 minus 0.798, so we can round it off. And then when I do 1 minus my answer, my previous answer, I end up getting 0.202. Okay, so here I went ahead and wrote 1 minus P is the probability of C is less than 11, and then I rewrote the 1, and here I got, for the calculator, I got 0.798. Subtract the 2, you get 0.202. So that's the probability that your strength is going to be greater than 11 inch-pounds. Okay. All right. For B, that's A. For B, it says explain why it is reasonable to assume that the cap strength and the torque applied by the machine are independent. Okay, so since the machines that that are creating these the torque and the cap, since they're being created by two different machines, then we know that they're going to be independent. So that's pretty much it. So it says here, why is it reasonable to assume that the cap strength and the torque applied by the machine are independent? Because the cap strength and torque are independent because the machines are different. So the machine that's applying the cap that has the cap strength is different than the machine that's applying the torque. So they're two different machines, okay? All right. Let me know if you have questions on that tomorrow. All right, the normal distribution with mean 6.8 and standard deviation of 1.6 is good description of the Iowa Test of Basic Skills, ITBS, vocabulary scores of 7th grade students in Gary, Indiana. Call the score of the randomly chosen student X for short. Find the probability that X is greater than or equal to 9 and interpret the results. So if you draw this out, okay, so it says the mean is 6.8 We know the standard deviation is 1.6. We want to know when it's greater than 9. So here's 9. We want to know when this is greater than that right there. So we want to know that area, okay? Let me show you the different way of doing this, okay? So I'm going to do second vars, normal CDF, and I'm going to do my lower bound. So since my lower bound here, I'm not going to do it the way I did it up here, okay? My lower bound is 9. I'm going to put 9, comma. My upper bound is something that's very, very large. So I'm going to put 10,000, okay? Comma. The next step is my mean, so it's 6.8. 6.8, comma. My standard deviation, which is 1.6. So 1.6, close that up. And the probability of random chosen student from 7th grade for vocabulary score is 0.085. So that's about 8 to 9%. So that's pretty low percentage. So it says here to interpret the results. So we're going to put here the probability that a randomly selected 7th grader from Gary, Indiana, scoring higher than a 9 on the ITBS is 0.085. Okay, and here I just put 0.085. All right, so that's not too bad. All right, the last one here. It says professional tennis player Rafael Nadal hits the ball extremely hard. His first serve speeds follow a normal distribution with mean of 115 miles per hour, and standard deviation looks like I forgot that. So let's go ahead and let's put 5. I don't know how I forgot that number. So it's going to be 5 miles per hour as a standard deviation. Choose one of Nadal's first serves at random. Let y equal its speed and measured in miles per hour. So it says here, find the probability that his speed is going to be greater than 120 miles per hour. Okay? All right, so that's going to be equal to, let's go ahead and pull out our calculator real quick. So we're going to do second vars. I'm going to do normal CDF. Okay, so we want to know when it's greater than, so we can use the trick that we applied above. So 120, comma, a large number, 10,000, comma, the mean. What's the mean? 115. And then my made up standard deviation of 5. And then I go ahead and close that up. And then I get 0.158. Let's be, or 0.159. 0.159. So it's about 15 to 16% of chance that he's gonna hit that as fast. So here we're gonna go and interpret the results. So we're gonna put the probability Nadal's speed is faster than 120 miles per hour is 0.159. Okay. All right, the next one. So it says, what is the probability of this speed being greater than or equal to 120? So we know, because it's continuous, that this is also going to be equal to the probability that it's just greater than 120, which is 0.15, because, here's our justification, because y is continuous. Okay, simple as that. All right, C, it says find the value of C such that the probability of y less than or equal to some C value is 0.15. So here's what we're going to do. We're going to draw it out so you guys can kind of see it. Okay, so we know that the mean is 115. We want to know when the 0.15, when it's less than some C value where the area is 0.15. So since it's less than, we want to know where it's 15% here. So 0.15. We want to find out what the C value is. Since from here, sorry about that. Light went out again. So from here and on is 50%. That's why I knew to put it here, because this is 0.15, which should be less than 50%. So we want to find the c-value, and I showed you guys on the calculator last time how to figure this out. So you're going to go to second vars, and you're going to go to inverse norm. So here what they're looking for is the area. So we know the area is 0.15. They're looking for the mean. We know the mean is 115. And we're also looking for the standard deviation, which is 5. Okay. So here we're going to close that up, and we get 109. So that means that the speed is going to be 109.81. So that means C is going to be equal to 109.81. So that's the probability that he's gonna, that's how fast the ball's gonna go. Okay, so the probability that he's gonna hit it this fast is 15%. Okay.